Welcome to lesson 3-3, solving equations by adding or subtracting. We have two terms on this page. Inverse operation, operations that undo each other, such as addition and subtraction. Since we're only talking about addition and subtraction, I'll show an example. If I were to take the number 3, I say to myself, what can undo a positive 3? And that would be a negative 3. And that gave me 0. So that's proof that I undid the positive 3. My answer was 0. We could also do that with a negative number such as negative 4. What undoes a negative 4? Well, a positive 4. And when I put those two together, my answer is 0. So I know that I undid the negative 4 by adding a 4 to it. Equivalent equations, two or more equations with the same solution. All right. Do these two equations have the same solution? Does x plus 4 equals 7 is the same as x is equal to 3? Only if the x in the first one equals 3. We could do mental math here. We know that 3 plus 4 is equal to 7, so x must be equal to 3, and yes, they are equivalent. We use two key concepts. The first one is subtraction property of equality. What it means is, or what it says, if you subtract the same number from each side of an equation, the two sides remain equal. Right? What's really important is that we must maintain our equations. They must be the same. So if we decided, like in example number 1, if we decide that 5 is equal to 5 and we wanted to take away 3, whatever we do to one side, we have to do to the other. And you can see here, what I mean by sides is the equal sign. We have a left side and a right side. When we do the same to both sides, we maintain that equality of our original equation. 2 is equal to 2. In our second example, you can see x plus 2 is equal to 3. We're going to use the subtraction property of equality to find out what x is equal to. So we want to isolate our x, or get x all by itself. Notice that the x has a plus 2 with it. So to get rid of it, we're going to subtract a 2, and whatever we do on one side, we do to the other. And once again, I remind you that we know what the difference between left and right is according to our equal sign. When we subtract or simplify both sides, we now know that x is equal to 1. Our second key concept is the inverse of the first one. This one's the addition property of equality. Same basic concepts. In our first example here, we have 6 is equal to 6. What if we wanted to add 3 to the left side? And if we do, whatever we do on one side, we have to do on the other. And I'm going to remind you again, we know the left and right according to the equal sign. When we do add the 3's to both sides, we notice that we get 9 is equal to 9, and the equality of the equation stays the same. We can take the addition property of equality and apply it to this equation in our second example. We want to know what x is. We want to isolate it, but we have a negative 2. How do we get rid of that negative 2 or make it equal to 0? Well, we add its opposite, but whatever we do on one side, we got to do to the other. So we added 2 to both sides to keep our equation equal on both sides. And we end up with x is equal to 7. Alright, on this slide we're going to do some of our own work. It says solve x plus 8 is equal to negative 5. Then it also says check your solution. So we got two things we have to do, or two things going on in this problem. So let's go ahead and solve the first part. X plus 8 equal to negative 5. Alright, so now I got to say to myself, what is x equal to? And I can't do that until the plus 8 is 0. And the only thing that can do that is the inverse, subtract, of the same number. We know that the inverse property says when we add opposites, the answer is 0. We also got to remember that we're using the subtraction property, so whatever we do on one side, we do to the other. Alright, so let's go ahead and bring down the x. Very important that we bring down the equal sign. We don't have to add the 0 to the x because the 0 property says that it doesn't change it, or the identity I should say. Now we just got to do a little bit of work here. We have a -5 and a -8. The signs are both the same, so that means I'm going to go ahead and add 5 and 8. Gives me 13. Since the signs are both negative, I'm going to go ahead and keep the negative. So -13 is the answer. Now how do I check? This is where we plug and chug. Wherever there's an x, I plug it in and I go ahead and solve, and I say to myself, a -13 plus an 8. Signs are different. I subtract, I get 5. 13 is the largest absolute value, so I keep the negative, and a -5 does equal a -5. On this page it says graph the solution of 16 plus x is equal to 14 on a number line. Well, before we work on the number line, let's find out what x is equal to. I'm going to rewrite it. 16 plus x is equal to 14. This equation seems a little bit different than the last one we did. The x is next to the equal sign. Well, we could still solve this. We still want to isolate x. What we really need to do is look at the 16. What is in front of the 16? That's the most important thing. Look in the front. There's nothing in front of it, so we know that that 16 must be a positive 16. And the only thing to undo or inverse a positive 16 is a negative 16. That'll give me the 0. Now, we have to keep our equation equal, so whatever we do on one side, we do to the other. Bring down the x. Bring down the equal sign, very important to do. Let's go ahead and simplify 14 minus 16. These signs are different, so I know that I'm going to subtract. I'm going to put the larger of the two absolute values, so that's 16 on top, 14 on the bottom. 2 is the answer there. Now I have to reevaluate that 2. Is it a positive or negative? Negative 16 is the largest absolute value, so I'm going to keep the negative. So x is equal to -2. Now we're just going to write a number line. Since I know my solution is x is equal to -2, I just need to build a number line that has enough information for someone to gather where it should be on a number line. So I'm going to put 0, I'll put 1 there, put a -1 on the left side, and I'll put a -2. Since x is equal to -2, I'll use a closed dot to represent that it's just 2, nothing else. On this slide, we have solve y minus 7 is equal to -25. So before I do anything, I'm going to rewrite it. Now I want to know what y is, so I want to isolate it. It's not isolated because I have a subtract 7 or a -7. The opposite or inverse is a plus 7. And whenever I combine opposites, the answer is 0. Now to keep the equation equal, whatever I do on one side, I do to the other. I'm going to go ahead and bring down my y. No need to bring down the 0. Remember to bring down the equal sign. Now I got to just figure out what this is. I have signs that are different. So I have 25 minus 7, because when signs are different, we subtract. I get 18. Now, my answer is a -18 because the 25 has the largest absolute value, and I keep that sign. So I now know that y is equal to -19. And to get in the good habit, let's check the solution. How do I do that? I take the original equation, wherever there's a y, I put a -18. There we have a -7. It's equal to -25. I'm going to go ahead and simplify the left side of the equation. The -18, I'm going to change the subtraction of the -7 into a positive. 7 goes to a negative. Oh, the signs are both the same. So that means I'm going to go ahead and add since the signs are both the same. 18 and 7 make 25. Both of the signs are negative. It does check out. So apply what we've learned and use a word problem. Write and solve an equation to find the length of Wilbur Wright's flight. Well, let's read what our paragraph here. On December 17th, 1903, the Wright brothers made the first flights in power-driven airplane. Orville's flight covered 120 feet, which was 732 feet shorter than Wilbur's. So let's try to find Wilbur's length. Here's what I do know. Orville was 732 feet shorter than Wilbur's. Alright, so that means I don't know what Wilbur's is. So I'm going to use a x to represent the length of Wilbur's to find my variable. Okay, once again, Orville was 732 feet shorter than Wilbur's. So if I took Wilbur's, which I don't know, shorter than means subtraction, and that length was 732. It's got to be equal to something, and it says here in the original problem 120. You can see my equation now is x minus 732 is equal to 120. So now all I have to do is isolate the x. I can't isolate it until I get rid of the subtract 732. The inverse of subtraction is addition. In order to get to 732 to 0, I must have the exact same number. Whatever I do on one side, I do to the other. Bring down the x. Don't have to add the 0. Bring down the equal sign. Go ahead and add these two numbers because they're both positive. 258. Alright, 852 feet. And x is equal to the length for Wilbert. There we go.